Now we discuss about the different kinds of units. So already some definitions I have discussed with you. That is pole, center of curvature, radius of curvature, focus and focal length. So the relation between focal length and radius of curvature is the relation between radius of curvature and focal length. Focal length is R is equal to 2f. R is equal to 2f. Double the focal length we get the radius of curvature, or otherwise focal length to be calculated. Radius of curvature we know R is f is equal to R by 2, whatever it is. In these two relations, we have to find the relation between, that is either focal length or radius of curvature. So R is equal to 2f or f is equal to R by 2. Now, I have discussed about by using the concave mirror how to find the object and image distances, or focal length of the lens also to say in this time. Focal length of the lens. How to find the focal length of the lens, or how to find the object and image distances by using concave mirror. So one lab activity you have to conduct. One of the lab activity we had observed here. So aim of this experiment to say to find the object distance. Object distance is said to be u, and image distance is said to be the v. So to find object distance and image distance by using concave mirror. Why have you used concave mirror? Because it is a converging mirror. That's why I had to use in this determination this concave mirror. Okay. Otherwise, this question also to given how to find the focal length of the lens. By that also I had to use same. Now, what are the operators need for verifying this? Required operators. The operators needed for verifying this experiment is said to be one V stand, concave mirror, meter scale, and we need one paper screen, and we need candle. These are the required operators. By using these operators, we can verify the distance, object distance, and image distance or focal length of the lens. Now, how to arrange this? Arrangement of operators. So, in a horizontal surface or horizontal table, I have to first arrange one meter scale. 1 meter scale arranges like this. This is said to be the meter scale to imagine. So match the two values of meter scale. to arrange like this on this metal plate to place at certain distance V stand. V stand is to be placed is said to be the V stand. V stand is to place on this to place the concave mirror. To place the concave mirror like this, and another side to place object. Object is here candy. To place one candy. This is said to be the candy to be placed at one side. To place a candy, and on paper screen to be place and adjust that paper screen to place the paper screen. That means paper to attach it to one pad. It becomes as a paper screen. So to make adjustment of this paper screen and to move it to and fro at one particular instant, you have to get the clear image of object, that is candy. Candy image, you have to clear sharp image, you get it on this paper screen. When you stop that and to measure the distance. So this distance is said to be the image distance. It is V, and this distance you have to call as, that is from mirror to this mirror to this an object. From this object distance you have to say as image distance U. So by adjusting that white paper, that is paper screen, you have to get a sharp image. When you get the sharp image, you stop the rotate of this screen and to observe the distance. The distance gives the image distance already, and one fixed position you have to place this object. Such a distance we consider as U, and V is the, by observing, by changing the position of this screen, we get one value that's said to be the sharp image. When you get the sharp image, then only to measure the distance. That gets the image distance V. Okay, in this manner we have to find the object and image distance. Then later, by changing different places of this object, we get different images. Then what kind of images are formed and what is the relation between them? All such things, just to have to imagine one values, and according to that we can guess this one. Okay, understand? Here in this experiment what you have to say, to arrange one meter scale on horizontal plane at one particular distance, to place the V stand on that. What is this? So what's also to indicate this said to be the V stand. On that to place the concave mirror. Concave mirror is to be placed, and opposite distance to measure the distance exactly. At that to place one burning candle, and take paper screen. It is the paper screen, and to make the adjustment of this paper screen, to move it to and fro. Then we get at one particular instant sharp image of the object. Then at that time we had to stop and measure the distance, that gives the image distance V, and already candle will be placed at one fixed value, that is the object distance. So by knowing these values, we can calculate the focal length of the lens also, and also the here in this case you have to measure the what kind of image is formed, where the images are formed, like that. Just one simple example I will show it. Okay, so understand this experiment. Now just by keeping one simple a demonstration. So one numerical values to be considered, numerical values to be taken by saying this natures of the images formed by it. Okay, now I have to consider in this we get them. So we consider as a table 1. Table 1. In this we consider serial number, object distance. Object distance is said to be u centimeters, and image distance. Image distance is said to be v taken centimeters, and bigger or smaller than the object size to be considered, bigger or smaller than object, and it is erect or inverted. So erect or inverted image will be formed. So this first we have to fill the table. So just by considering some values, then for this you can draw the array diagrams also for this. To consider these values, just to be considered a numerical value, say 40 centimeter, object is placed at 40 centimeter, image is formed at 24 centimeters. This is smaller image will be formed, that is smaller than the object, so its nature will be inverted image will be formed. So in concave mirror all images are inverted only except at one condition, so we have to show it in array diagram. And next to change the distance 30 centimeters, we have to say 30 centimeter image is also formed at 30 centimeters, then same size. So same size of the object will we have to observe, same size of the object, and it is also inverted position, inverted. Next, distance to be reduced 20 centimeters. Image will be formed at 60 centimeters. Image is formed at 60 centimeters. It is bigger than the object. It is also in inverted position. It is also inverted position. Next, to say at 10 centimeter, image is formed at 71.25 centimeter distance. It is also bigger than the object, and it is also inverted. Inverted image will be formed. So that means only the nature and sizes of the images by placing at different positions, so I had observed in this condition. Okay, at 40, 24 centimeter, that is less than that of the object distance, it will be formed. It is a smaller and inverted position. And next 30 centimeter then 30 centimeters, so same size. When both values, image distance equal to the object distance, same size of the image is formed. It is also an inverted position, and object distance will be less than that of the image, that is at 20 centimeter at place, image is formed at 60 centimeter distance, then it is bigger in size, it is also inverted. Next, at 10 centimeters, it is 71.25, it is also bigger and inverted position. Okay, this is one of the table by considering the different positions. Similarly, we say object distance such as at pole and between pole and focus, like that to be considered, where the images will be formed and what kind of images we had observed. That also had to say in another table. So in table 2, I had to say them positions of the object to place such properties of the concave view. Okay, that is pole, focus, center of curvature will be there. No. So according to that, you have to place the images where the object is formed and what kind of images are formed. All such things we have discussed in this table. So it's a table 2. So in this we have to consider serial number and the position of the object, position of the object and position of the image, and the nature of the image, nature had to keep nature of the image. So in this nature you have to consider enlarged or diminished. Enlarged or diminished image is formed, or erect or inverted, and real or virtual. So these conditions are observed by placing different positions. Now, at first question I have to say between pole and focus. Between P and F. P means pole and F means focus. So between pole and focus object is placed. The image is formed behind the mirror. It will be formed behind the mirror, and it is enlarged image will be formed. Enlarged image, and it is erected. This is only the erect portion. In remaining all the portion, image is inverted and it is vertical. Vertical image is formed. So at this condition only, where object is placed between pole and focus. Pole and focus we have to place. The image is formed behind the mirror and it is larger than the object and it is erect and vertical. This is the first condition. And exactly image is placed at focus. At F means focus, the image is formed at infinity. Image formed at infinity. This is also enlarged image. It is inverted position. Inverted position, and it is a real. So in all conditions, inverted, real had observed. So where at F had placed, F means focus. Next, object is placed between focus and center of curvature. F and C. F and C means focus and center of curvature. Image formed beyond center of curvature. C means center of curvature. Here also enlarged image is formed. It is also inverted and real in nature. Real inverted image is formed. Next, object is placed at center of curvature. Image is formed also at center of curvature. Same. Object distance and image distance must be equal in this condition. Where which condition? At C. C means center of curvature. So object is placed at center of curvature. Image is also formed at center of curvature. It is same size of the object. Same size of the object. So there is no enlarged or diminished image is formed. Same size at this condition, where C means at center of curvature. So it is also inverted and real. This condition is same. Real and inverted images are formed. And next, beyond C. Next condition I will say beyond C. Beyond center of curvature, object is placed. Image formed between F and C. F means focus and center of curvature. It is diminished image is formed. it is also inverted and real image. So for all this we have to draw the ray diagrams, also we have to show this. Now these different questions we have to place the object. Now at different positions images are formed and their nature we have to observe. First condition, that is object placed between pole and focus only, erect and virtual images are formed. In remaining all the conditions, images are inverted and real images are formed. Remember that. So this is the, for using that experiment, we have concluded these positions of the object and image distances. Okay. Then next we have to discuss about the ray diagrams.